Hello fellow researchers, professors, and animal enthusiasts. My name is Dhiraj Ramireddy. While I was studying abroad in Costa Rica, I conducted an independent study regarding the function of crocodile hatchling distress calls. This study began with a field observation. When a hatchling was picked up, it vocalized, and a few other siblings responded and approached it. This begged the question, why do crocodile hatchlings vocalize? Previous studies determined the elicited call as a distress call. Its spectrogram is shown on the slide. The hypothesis for the study states that a captured hatchling will vocalize a distress call to seek help from siblings. To support this, I would need to see similar reactions as the initial encounter on multiple trials. To recreate the first observation, I devised a method broken into 4 parts and completed 5 trials. Phase 1. The pre-capture. As Hilber, a local parataxonomist dressed in blue, approaches the subterranean den with a noose tied to a stick, I, in yellow, would record visual and acoustical data. In Phase 2, the capture, Hilber holds the vocalizing crocodile as seen in the blue circle. I recorded visual and acoustical data of the captive and its siblings in the den using binoculars and a recorder. In Phase 3, the release, Hilber in pink holds the captive near the water for about 3 minutes. Again, I would record visual and acoustical data of the captive and siblings. The final phase was to observe all the hatchlings without interference, looking for a possible natural predation attempt. It may be hard to spot me behind my upscale camouflage, so I put an orange arrow to help you out. In 3 of 5 captures and 5 of 5 releases, the captive hatchling vocalized a distress call. There was always a response to a distress call from at least one other sibling. Drawing your attention to the bottom left, you notice a dark blue spectrogram. This plots the harmonics of the calls vocalized by the captive, highlighted in red, and the siblings, in green. The ones highlighted in red are similar to the distress call harmonics in the introduction, a sharp spike in frequency followed by downward sloping harmonics. You may also notice that one distress call can have multiple responses or just one. In 4 of 5 captures and 3 of 5 releases, at least one sibling was witnessed to approach the captive. Off to the left, you see a contingency table that shows the relationship between a hatchling's movement and the presence of a human, a potential predator. A Fisher exact test showed that the relationship was significant, with a p-value less than 0.05. Thus, a hatchling would only approach if a human was holding a captive. And despite sitting patiently behind a blind for 20 hours, I found no additional evidence. So to conclude, my hypothesis was supported. When captured, a hatchling will vocalize a distress call to seek help from siblings. This was shown by the vocal responses displayed by the spectrogram and the movement significance calculated through a Fisher exact test. Both of these behaviors are certainly a paradox. Both would endanger the siblings to potential predation, yet they still do it. The benefit of their action must somehow outweigh this risk. Thus, both behaviors must be looked at through a cooperative lens. These behaviors among siblings cooperate to increase the likelihood of attracting the mother crocodile. This novel study was significant in finding the nuances of crocodilian communication. Instead of directly alerting the mother, as stated in the previous literature, the distress call may operate in an alternative pathway, a distress call to the siblings, who echo that call to alert the mother. This evidence opens up the poorly studied crocodilian communication pathways to more nuances that require further research. I would like to acknowledge Hilber for his assistance in capturing the hatchlings, Frank for his unwavering guidance as lead advisor, Emmy for her insightful knowledge as secondary advisor, and the Monteverde Institute. Thank you for your time and stay safe.